Hello everyone. For this video I like to discuss quadratic equations, as well as the most simplest ways to solve them. A quadratic equation is in its most simplest and convenient, or standard form, if it is in the form ax squared plus bx plus c equals 0. Exactly like how a linear equation is in standard form if it is ax plus b equals 0. Although this equation may seem overwhelming at first in terms of how to get a specific value for x, we can see that there is a simple method called solving by factoring, which states that since, in simplest form, the equation is exactly equal to 0, it follows that at least one of its factors must also be 0, which makes sense from basic arithmetic properties related to multiplication. And we went over explicitly how to factor quadratic expressions in a previous video. So if we are given an equation like this, we see it may not be in standard form off the bat, but we can simplify it into standard form by subtracting 12 from both sides, and seeing that c is negative 12 and b is negative 1, we conclude that the factors must be negative 4 and 3 by the AC method. So in turn, we can conclude that x equals 4 or negative 3. Because x minus 4 equals 0 means that x must be 4, and x plus 3 equals 0 means that x must equal negative 3. If we are unsure about this, we can plug in both of these values into separate tests and see that 4 and negative 3 both check out once we do all the steps. If we have it in a form like this, which we cannot put in terms of ax squared plus bx plus c because we have no coefficients of x, we would simply assume the coefficient of b is 0, and then get it in standard form if needed, but in here it is already in standard form. So now we see by the AC method, 4 times negative 1 is negative 4. The factors that add up to 0 and give negative 4 are 2 and negative 2. So now we carefully think about the distributive property and see that unfortunately something minus 2 times something plus 2 does not work in terms of the original equation with negative 1 as our c value. So we will instead have to rewrite it as something minus 1 times something plus 1, where the minus and plus the same value is important in order for b to be 0. And we see another problem is that if we have a coefficient of m different in one term versus the other, then this would mean when we distribute it out, we have one of the terms greater than the other, so the net result will not be 0. This means that the coefficients of m also have to be identical in order to get a b value of 0. So we conclude that the answer must be 2m minus 1 times 2m plus 1 for the factored form. And now we set these individually equal to 0 and solve them as linear equations. And we conclude that m must equal 1/2 or negative 1/2. This makes sense because 1/2 squared is 1/4, and negative 1/2 squared is also 1/4 because a negative times a negative is a positive. So we see 4 times 1/4 in both cases is 1, and the other term is minus 1. 1 minus 1 simplifies to 0, and that is what we want to solve for if we have a quadratic equation in standard form. In conclusion, m equals 1/2 or negative 1/2. If we have something like this instead, we would see that the constant c is 0 instead of the coefficient b. But adding and subtracting 0 does nothing, so it is not appropriate to write out explicitly. So now we can see, fortunately for us, that this does not involve quadratic factoring like the AC method, because x is a common factor. So we can get it in terms of x times a linear equation, and conclude that x must either be 0 or the solution to the linear equation, which is 2/5. We see that 0 makes sense right away, because we have something times 0 on both sides, but 2/5 we will have to test. we get 2/5 squared is 4/25, which means 5 times 4 is 20, 20 over 25 equals 4/5, and 2 times 2/5 is also 4/5. We can see because we get the same arithmetic value on either side, this answer is also valid. Just like we saw that rational expressions can sometimes simplify to linear equations, this is exactly as true with quadratic equations. As for example, if we are given this, we multiply everything by the least common denominator, see the fractions go away, and that we have an x squared on the right hand side but not on the left hand side, so we can't cancel it out. But what we can do is rearrange the equation to get a quadratic equation in standard form by combining like terms and adding and subtracting terms on the left hand side to get it to 0, and then solving it by factoring. When we solve it by factoring, we get x equals negative 1/2 or x equals 5, and we will have to test both of these values to make sure we are accurate. We have 1 over 1/2 on the first term on the left hand side, which is 1 times 2 is 2, and 2 times negative 1/2 on the right hand side denominator is negative 1. Negative 1 minus 4 is negative 5. 5 over negative 5 is negative 1. 1 minus negative 1 means 1 plus 1, so we have 2 on the right hand side. Since we have 2 on the left hand side from what we saw earlier, x equals negative 1/2 is the solution. We test x equals 5 as well. We get 1/6 on the left hand side. We get 2 times 5 is 10, 10 minus 4 equals 6 on the denominator in the right hand side. And we see we have 5 in the numerator. 1 minus 5/6 is 6 over 6 minus 5 over 6, which equals 1/6 when we do the arithmetic. So we conclude, since both sides are 1/6, x equals 5 is a valid answer as well. If we have something like this, we can demonstrate a caveat regarding these types of problems by doing an example like this. We first find the least common denominator, which is x minus 1. Multiply both sides by this. See that the fractions cancel out, but we get a quadratic expression on the left hand side. We simplify it by combining like terms, and then get it in standard form by subtracting and adding terms from the right hand side to get it equal to 0. We solve this by factoring, and see that unfortunately x minus 1 is in the denominator of both side fractions, so we would get division by 0. So we conclude that even though we got a quadratic expression by taking the appropriate steps, this quadratic equation has only one solution. So many times it will have only one or no solutions. So you will have to analyze each problem on a case-by-case basis, and you can never assume it will always have two solutions. Now that we've gone extensively over solving by factoring, we can discuss solving by the square root property next, which is that if x squared equals n, then x must logically be positive or negative square root of n, where the negative part is important because a negative value that has the same absolute value or distance from x as its positive counterpart will give you the same answer squared as the positive counterpart, because of how multiplying a number by itself works. So if we are asked to solve something like this, we could solve by factoring, by doing x minus 10 and x plus 10, but the square root method can come in handy in many cases, so we will do that instead, as it is not always possible to solve by factoring directly. So when we do this, we get x squared equals 100 to get x squared equals n, where n is 100. So we conclude that x must either be positive or negative 10, which is what x minus 10 times x plus 10 equals 0 also demonstrated, but this is a much more quicker method. Complex numbers are used here because sometimes we will get a negative number for n, and we know the imaginary number is the square root of negative 1. For example, If we are given this equation, we see that n equals negative 49 over 4 after simplifying. So this simplifies to I times the square root of 49 over 4, positive or negative, and the square root of 49 over 4 simplifies to 7 halves. Because of the fact 49 is a perfect square of 7, and 4 is a perfect square of 2. So in its most simplest form possible, x is exactly equal to positive or negative 7 halves times I. And this is one case where solving by factoring would get us stuck, because we would not have any answers with normal or real numbers using that method. Sometimes the square root property will be done earlier in the problem instead of the very last step like we've been doing so far. As in this case, we undo the squared part on 2t minus 9 by taking the square root positive and negative of both sides. This simplifies to 2t minus 9 equals positive or negative square root of 5. So now we solve the cases where it is positive or negative, as if it was two separate linear equations. We first add 9 to positive or negative square root of 5, and then multiply everything by 1/2. Once we do calculations for more exact answers that do not involve square root symbols, we unfortunately get messy decimal answers because of how square roots of anything besides perfect squares work. But we can see it is approximately 5.61 for the positive case and 3.38 for the negative case. If we want to verify that our work is accurate, we would use the form with the square roots instead of the decimal answers, so that we have a precise answer that is more easy to verify. So when we do this, we see that in either case, 9 halves times 2 is simply 9, and positive square root of 5 over 2 times 2 is positive square root of 5, and negative square root of 5 over 2 times 2 is negative square root of 5. So when we do the distribution, the 9's cancel out in either case. So we have positive or negative square root of 5 squared equals 5, which we know is true by definition of the square root property. So we conclude that both of our solutions are valid. We will do one last example that is more complicated to get us adjusted to more advanced quadratic equations in the next video. In particular, if we have this example, we see that we are taking the square root of a negative number, so imaginary numbers get involved again. 3x plus 10 equals positive or negative 9 times I, after simplifying our work. So now we subtract 10 from both sides and divide by 3. Quadratic expressions in this form often show up, so we will discuss more complicated methods such as completing the square and the quadratic formula in the next video, as well as explain how they are intertwined. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.